Hi everyone, the question is the number of solutions of the equation x square plus y square equal to a square plus b square plus c square where x, y, a, b, c are all prime numbers is. So here there is just one even prime number which is 2 and rest are all odd prime numbers. Now if x, y, a, b, c all 5 of them are odd prime numbers, then left hand side would be even because square of an odd number is odd, so left hand side would be odd plus odd even, and right hand side would be odd plus odd plus odd. So that means x, y, a, b, c all of them can't be odd prime numbers. That means at least one of these 5 values x, y, a, b, c should be even prime number, which is 2. Also please consider this, that square of an odd number is of the form, let's say 2n plus 1 is an odd number whose square I am considering, so it will be what, 4n square plus 4n plus 1. So that means square of an odd number is of the form 4k plus 1. That means if you divide square of an odd number by 4, the remainder is 1. Now let's first consider the case where only left hand side has the term 2 square and right hand side has all the terms being odd. That means a, b, c are all odd. That also means a square, b square and c square are odd. So in this case only left hand side I am allowing that any of the term 2 square, that means x or y, any of them can be 2. So here depending on whether only x square or only y square or both x square and y square are having or are equal to 2 square, the remainder of left hand side when you divide by 4 is either 1 or 0, because if both are 2 square, then when you divide left hand side by 4 the remainder is 0, and if exactly one of these two, x square or y square, is 2 square, then the remainder of left hand side when you divide it by 4 is 1. And since right hand side is not having any term being 2 square, that means a square, b square, c square all are odd prime ka square, then when you divide it by 4 the remainder is 3. So that means only left hand side having 2 square term gives us no solution. Now let's come to the case 2. Only right hand side is having 2 square term. Now if right hand side is having 2 square term and left hand side is not having 2 square term, that means left hand side x square and y square both are squares of some odd prime number, the remainder that would be there on left hand side when you divide it by 4 is 2. So should happen on right hand side if equality is to hold. So that means exactly one of these 3 terms, a square, b square or c square, should be 2 square, and rest 2 should be square of odd prime number, so that on right hand side also when you divide right hand side by 4 the remainder is 2. Now this is a necessary condition but not sufficient condition. If both sides when divided by 4 give remainder 2, then then they can possibly be equal. The both sides can possibly be equal. If both sides when you divide by 4 and they are giving different remainder, then left hand side can't be equal to right hand side in any way. So let's say without loss of generality a square is 2 square, and mind you that means b square and c square are squares of some odd prime numbers. So here you may consider x square minus b square plus y square minus c square equal to 2 square, which is 4. Now my claim is given that x, b, y, c are all odd prime numbers, let me take x to be 2m plus 1 and b to be 2n plus 1, let's say. So 2m plus 1 square minus 2n plus 1 whole square. The claim is x square minus b square and y square minus c square both are divisible by 8, whereas on right hand side, which is 4, is not divisible by 8. So that means again you would not be getting any solution in case 2 also. For that, let me just prove it that if x and b both are odd prime numbers, or you may just say if both are odd numbers, then difference of their squares would be divisible by 8. So what you get is, you may say 2 times, or rather if you see carefully, it will be 4 times m plus n. Oh, my bad. 4 times m plus n plus 1 multiplied by m minus n. So here m and n, either they can be even, odd, whatever. The point is, if m minus n is odd, then m plus n plus 1 would be even, and if m minus n is even, then m plus n plus 1 would be odd. That means out of these two factors, one would be even and other would be odd. The point is, this means 4 times, since one of these two factors, m plus n plus 1 or m minus n, would be even, so that means effectively this whole expression 4 times m plus n plus 1 multiplied by m minus n is a multiple of 8. And that's what I'm trying to say, that x square minus b square would be multiple of 8, y square minus c square would be multiple of 8. So that means left hand side is multiple of 8, but right hand side is not. So that means even in case 2 we are not getting any solution. Now you may say, sir, what if both sides a 2 square term may be there? So without loss of generality, if both sides are having 2 square term, that means we are saying both sides are having at least one term which is 2 square. So let it be that x square is 2 square and here a square is 2 square. So essentially it cancels out, and what you get is y square equal to b square plus c square. So here don't think in terms of Pythagorean triplet. Why? Because here y, b, c are supposed to be prime numbers. Yeah. So here now let's consider further possibilities. What if y is some odd number, that means odd prime number, then left hand side when divided by 4 would give you remainder 1. So should happen on right hand side. That would mean what? Out of b square and c square, one of them should be again 2 square. Yeah, when when y is odd prime number. Yeah, so you have, let's say b square is 2 square, which is essentially 4. So again, as I have already proved that a difference of squares of two odd numbers is multiple of 8. Left hand side is multiple of 8, right hand side is not multiple of 8. So again, you don't get anything from this case. So again, just to recap, if y square is not 2 square, that means y square is square of some odd prime number, then right hand side, since left hand side is odd, right hand side should also be odd. That means one of these two terms, b square c square, should be 2 square, so that one of them becomes even and the other is odd. So without loss of generality, I have taken b square to be 2 square and c square is square of some odd prime number. So that's how it is. Left hand side is multiple of 8, but right hand side is not. Another possibility is when y is equal to 2 square. Yeah. Now if y is equal to 2 square, then if b and c both are odd prime number, then again right hand side when divided by 4 would give you remainder 2, because b square would give you remainder 1 and c square would give you remainder 1. So, and left hand side doesn't give you any remainder when divided by 4. So again, b square and c square both can be square of some odd prime numbers. So what about one of them being 2 square and other being a square of odd prime number, but then left hand side is even and right hand side is odd. So what about both being squares of even prime number, that means both being 2 square terms, that means b square is also 2 square, c square is also 2 square, but then left hand side is not equal to right hand side. Yeah, so no matter what, you don't get any solution from here also. So we have considered all possible cases, all possibilities we have explored, and we haven't got any solution for this equation x square plus y square equal to a square plus b square plus c square, where x, y, a, b, c are all prime numbers. So that means number of solutions is 0. A is the answer. Thanks for listening.